Welcome to my channel. Today we're looking at set. So under set we're going to look at definition. That's definition of set, characteristics of set, method of representing set, types of set, terms used in set, Venn diagrams. So we'll solve exam questions. So we'll start with definition. So a set is a collection of distinct objects, things or numbers. The object which make up the set is called the element. So see what we are looking at. Okay, for instance, a set A contains elements A, B, C, D. So if you have a set that contains A, B, C, D, we normally denote it by this. So A is the set. So once you write the items inside called the members, you enclose it in a curly bracket. So that's the bracket that we use in set. We don't use this type of bracket. So this is not a set. If you see something, if someone writes A is equal to A, B, C, D. So this is not a set. So it must be this type of bracket, curly bracket. So that's it. So each of these is called the element or the member. So which is A is the element of A, B is an element of A. So that's it. So the next thing is the characteristics. Okay, we have that the first thing we have to know under it that the elements are enclosed in curly bracket as I've said before. While the second one, the elements are separated by a comma. So once you write a set, maybe if you write set P is equal to, you cannot just write the element like that. No. So this thing means just one item. So you need to separate them with a comma. And no element is repeated. Yes, we don't repeat element in sets. Maybe if you have a set that has maybe B 2 times, so this is not allowed in sets. As you can see, we have 2B, but we don't write it in sets. We just write one of it. So that's this third characteristics. And the fourth one, ordering of element is immaterial. So we don't order like this. We can still write the set P as B, A, D. So order doesn't matter. So that's the major 4 characteristics of set. So the next one is now representation of set. So to represent set, we use 2 methods, by roster or listing method. This will list 1 1. As you can see, the elements are A, B, C, D. We list. Or the second one, we use set builder notation. Like this, they said B. The set inside B must be a multiple of 6 within this boundary. Do you get? So that's another way of writing set. So whenever you have a multiple of 6 within this boundary, that's between -2 and 20. So that's another way of writing set. It's called set builder method, or you list. So we're done with method of representing set. So the next one, types of sets. So under types of sets, we have finite set. That's a set that you can list the elements. Yes, that has a finite number. As you can see, A, B, C, D. You can list it. Infinite set is the one you cannot list. Yes, that has infinite number of elements. Like this, B is a multiple of 6. So we have a lot of numbers that are multiple of 6. So you can list. So why we have null or zero sets? So a null set is a set with no element. So if you don't have any element or member inside, so it is denoted by this, an empty curly bracket or this. So once you see this or this, it means a null set. So there's what we call singleton. Singleton is just a set with one member, as you can see, one element. So that's what we call singletons. So we'll look at the terms using sets. Okay, terms used in set, we have subsets. So if you have two sets A and B, that's A and B are two sets. If every element of A is in B, then A is called the subset of B, and it's written this way. So A is a subset of B. Thus, A is a subset of B means A is a subset of B, or A is contained in B. So if you don't call it that A is a subset of B, that's A, or you call it, or you say that A is contained in B, meaning that you can find the elements of A in B, or B contains A. We can also write it as B is a superset. So this, the opposite of this sign, is the superset. So B is the superset of A, means that B contains A. That's the same. So if A is a subset of B and there exists at least one element in B which is not in A, we can then say that A is a proper subset of B, or B is a proper superset of A. So it's written, if you notice, there is no, I would like call it equality down here. See the difference? So this means that A is a proper subset. So see what I'm saying? You can see that maybe if you have set A with element 1, 2, 3, and you have B with element 4, 5, 1, 3, 2. So we can see that every element of A is in B. So we now say that A is a proper subset of B. But if maybe if A is this and B is just maybe, okay, let's use another. If P is A, B, C, D, or maybe just A, B, and Q is A, B, C. So we can say that P is a subset of Q, but not a proper subset. So do you see it? That's the difference. This one has an extra element aside the ones in A. So that's what we are saying here. That if B has an extra, if there is at least one element in B, we say that A is a proper subset of B. So that's it. So the next one is universal set. A set from which all other sets under consideration in a problem are drawn from is called a universal set. It is denoted by this, though we have a second sign symbol for that. Some textbook, they can use this. So either you use mum or that. So see what I'm saying, that if you have this called a universal set, if you notice that zooming is a universal set, if you have the element maybe 1, 2, 3, 4, 5, 6, you now have other set, maybe that's subsets. Maybe if you have 2, 3, maybe another set, maybe 5, 6, maybe another set R, maybe you have 4, 5, 6. So you notice that all these sets, E, Q, and R, they are all gotten from this set. So this is called the universal set. So that's the meaning of universal set. So why complement of a set? The complement of set A is a set that contains the elements that are not in A but in the universal set. It is denoted by A prime or A raised to power C. So see what I'm saying? Looking at this, see our universal set. If you look at P has element 2, 3. So if you want to get the complement of P written as P raised to power C or P prime, means that the elements that are in universal sets but not in P. So any other element that are in the universal set but not in P is called the complement. So look at there, like you can see 1 is not in P, 2 is there, 3 is there, so 4 is not there, 5 is not there. See, so this is the complement of P. And maybe let's do R or Q complements. So we have 5 and 6 in Q. So other element, which is 1, 2, 3, 4, are the complement. That's it. That's the complement of that. Why finally? The complement of, you can write R prime. It are the elements that are in the universal set but not in, so which is 1, 2, 3. So these are the complement of this set. So that's what we mean by complement of a set. So there's what we call cardinality of sets. So we normally write it as, that's like absolute value of A. It's just the number of elements of a set. It's called the cardinality, as you can see. Like this, the cardinality of P. So if I say the cardinality of P now means the element here. How many elements are there? So it's a number 2. Why the cardinality of Q? How many elements? We have 2 again. Why the cardinality of R? How many elements? 3. So it's just a number of, once you count the element, the number is the cardinality. Okay, the next term is the power set. So the power set of A, that's a set A, is the set of all possible subsets of A. It means that is the set that can be formed using the elements in the set A. It is related to cardinality as the power. So that's the symbol for power set. So power set is given as 2 raised to power n, where n is the cardinality. Okay, let me explain. So see what I'm saying. Assuming you have sets maybe that A has elements, maybe A, B, C. So if you have power set of A, it's just that the set that can be built using the elements there. So it contains all the subset of this. So see what I'm saying? Like you can build a set with an empty set. Yes, it's also part of the set. An empty null set. Yes, we can build it as excluding an element. We can still have set A that contains only element A. We can still have B. We can still have set C. Yes, we can still have A, B. We can still have B, C. Yes, we can still have AC. And finally, we have A, B, C. So how many? 1, 2, 3, 4, 5, 6, 7, 8. Yes, power sets. So from this formula, you can still get it where n is the cardinality. Remember, I told you n is the number of elements. So the answer from the answer is 8. Or you can still solve it as 2 raised to power n, where n is the number of element 1, 2, 3, which is 2 raised to power 3. So without wasting time getting all this, we can still use this formula. So that's the meaning of power set. So the other one is the difference of 2 sets, or relative complement of sets. So the difference is just that if you have 2 sets and you notice that there is an element in one that is not in the other one. So I'm saying that if you have set A and B, A minus B means the elements in A but not in B. Or you write it as this. Or you write it as this. So they mean the same thing. So see what I'm saying? If you have maybe if you have set A to be maybe 1, 2, 3, 4, and set B to be 3, 4, 6. So if I have A minus B, it means the elements that are in A, but not in B. As you can see, 1 is there, 1 is here, but not here. 2 is there. Okay, none. So we have only 1, 2. So that's the answer. So that's the meaning of difference of set, or relative complement of set. So the other one is called the Cartesian product of two sets. The Cartesian product of set A and B, written as A times B, is the set of order pairs from A to B. Yes. So see what I'm saying, that if we use P, if I have P to be X, Y, and Q to be 1, 2, 3, that's the element 1, 2, 3. So if I want to get P, the Cartesian product of P and Q, it's just that I will build a set using this P followed by Q. See what I'm saying? We'll start with X. 1. That same X. 2. So what, do you notice something? So I'll count X, P before Q. Also, we have 3 remaining. X, comma 3. So we are done with X. We start with Y again. Y, 1. Y, 2. Y, 3. So that's it. So let's do for Q, Cartesian product of Q and P. So we start with the first element here is 1. So 1 comma X, 1 comma Y. We are done with 1. We start with 2 comma X, 2 comma Y. We are done with 2. We now do finally 3X, 3Y. So that's the meaning of Cartesian product. So the other one is equivalent of sets. Two sets are equivalent if they have the same number of elements. Yeah. Maybe if you have set A, B, C, Y set B, 1, 2, 3. A and B are equivalent set because both of them have the same number of elements, 3. And 3, 3. That's the cardinality is 3. So if they have the same cardinality. So equality of sets. Two sets are equal if they have the same number of elements. Yes. So if you have maybe P is 2, 3, 4. YQ is 3, 4, 2. These two sets are equal. P and Q are equal because they have the same elements. See, 2, 2, 3, 3, 4, 4. So you matter the arrangement. Once they have the same element, they are equal. So we have intersection of sets. The intersection of 2 or 3 sets is the set that contain the element common to the set. It is denoted by like an inverted cup. So see what I'm saying? If you have maybe with 2, 3, and 4, and N with 2, 5, 6. So if we want to get M intersection N from the definition, means the element that is common to both. As you can see, both of them have 2. So that's the answer. So element that have the same, that contain in both sets is the intersection. So Y finally, union of sets. The union of 2 or more sets is the set that contains all the elements in all the sets. So if you have, maybe if you have set A, 4, and you have set B, maybe 0, 2, 4, 5, 6, 7. To get A union B is like joining the two sets. So we start 0, there is 0, there is 1. Remember that we don't repeat elements. So there is 2, there is 3, there is 4, there is 5, 6, and 7. So that's it. If you notice, see for A 1 2 3 4 1 2 3 4, for B 0 2 4 5 6 0 2 4 5. So that's the union.